Thursday, yes, I know yesterday was Sunday and before that was Saturday, but Thursday, Friday, the last 2 school days, we've worked on this idea of the picket fence, and we're going to expand on that today and do grams to grams. So the first thing I need you to do is balance that equation on page 11. We've balanced this one a few times, so give that your best shot. A 2 in front of the 3, a 3 in front of the 2, and that makes 4 aluminums. All right, you will need your periodic table today because we're going to find grams a lot. So make sure you're with me on that. All right. So these are the longest picket fences, but usually this is the one that makes it click the most. So just stick with me and we should be fine. So it says how many grams of aluminum, so I might as well put that here. I know that's what I'm solving for. Were used to make 79 grams of aluminum oxide. All right. So it's the same process that we did the last 2 school days. You take the number and the unit that you're given, and you start here with it. So 79 grams of Al2O3. That's in the top left corner. Good? All right, then tell your lab partner, what does that tell you about this down here? Okay, good. It's grams, Al2O3. Tell your lab partner what that means about the top. All right. Grams is always 1 mole of the same thing, so 1 mole Al2O3 last time. Tell your lab partner what goes there then. A mole of Al2O3. All right. After that, there's nothing in this left part that tells me what goes in the top. So when I get stuck, I now work from the back. So 5 grams of Al right here. We know the unit at the end is the unit at the end, right? So grams of Al, which also tells me the bottom of that one is what? 1 mole of Al. And then that tells me the top of this one is mole of Al. Now, I have to put in all the numbers, but the setup is right. So I'm going to find these. The number in front of Al is the number in front of Al. The number in front of Al2O3 is the number in front of Al2O3. Okay, then I need to use my periodic table. I find the symbol for aluminum, and it has a 27 and a 13. So I use the bigger of the 2 values, right? So 27 is the mass of aluminum, but Al2O3, I need a little bit more work. So I have 2 aluminums. Each of them is 27. Plus I have 3 oxygens, and those are 16 each. I think this was 102. Is that right? Anyone already do it? Okay. It's 102. I put that in, and then I'm ready to roll. All right. So, I now, personally, I would for sure reduce this. 4 over 2 is easier to type into your calculator if it's 2 over 1. Right? So here we go. 79 times 2 times 27, and I divide that by 102. I just reduced them. It's like a fraction. 4 over 2 is the same as just 2 over 1. Yes. So hopefully we got 41.8. Raise your hands if you did get 41.8 when you type that in. Okay, that one should be easy. Please be careful though, if you look up here at the screen. If there's 2 numbers in the denominator, like let's say it was 102 and then like 7, the most accurate way to do it, if you don't have a calculator with parentheses, multiply the top, multiply the bottom, and divide both answers. There is a way to screw it up if you do it in your phones and you don't put the two numbers in the denominator. Okay, you with me? Let's do the next one. It's in your homework on page 14. So it's magnesium carbonate, when heated, decomposes into metallic, whatever, who cares. And then it says you have 20 of those and whatever. I will balance it. It's just 1, 1, and 1. You try the rest. So grams of MgO is what we're solving for. And then I'm going to come and start with my given. 20 grams of MgCO3. I don't feel like writing that, so I'm going to just say that this is represented with the letter A. Okay with that? That's cheating, but I'm going to do it anyway. So MgCO3 is A. So I have 20 grams of A, which means I have grams of A down here. Grams is always per mole, so I have 1 mole of A, and remember A is representing MgCO3 because I'm lazy. Down here I have mole of A, but I'm not done yet, but I don't know what to do next, so then I go to the N. Grams of MgO must be here. Alright, grams is always per 1 mole of the same thing, so that's MgO, which means that must be mole MgO. Now, these coefficients, whatever in front of MgCO3, which is the A, is a 1. The MgO is also a 1. So then I just have to find MgO is 24 plus 16. That's 40. MgCO3, which A is representing, that adds all up to 84, if I remember right. And then we're ready to do the math. 20 times 40 divided by 84. Does anyone have that number? 9.5 is the right answer. Sweet. We'll put that in a box. How many had 9.5? Raise your hands. Keep them up for me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No? Okay. 17, 18, 19, 20. No one here? We can still be friends? Maybe through some counseling. Okay, so about 20 out of 28 of you got it. That's not awful. Not what I was hoping for, but not bad. All right, are you willing, Curtis, to tell me where you got lost? So you got to here. Okay. So going backwards. Did it make sense when I talked through it? Okay. Anyone else willing to tell me where they got lost or stuck? Where at? The 40. Okay, good. All right, the 40. So anytime we have grams, we got to find it on our periodic table. Mg is a 24 and a 12. O is a 16 and an 8. It's just the big two numbers. You all right with that? Okay, anyone else lost in a different place? Okay, the next one, same page, right? I will help you with the chemistry because I'm that nice of a person. Gold 3 chloride decomposes into its pieces, which is just gold, plus chlorine, which is diatomic, so it's a 2. My pen is flipping out on me. To balance it, it's a 2-3 swap and then fix that. So 2, 2, and 3. Now, to save you even more time, gold 3 chloride has a mass of 303.5. That's what gold 3 chloride is. Gold is 197 grams. Okay, you'll use those in your picket fence. Take a few minutes and try that on your own. 60 grams of AuCl3. That means grams AuCl3 has to come down to the bottom. And that's the one I gave you, 303.5, and that's per 1 mole of the same thing. Coming down here then, that means mole AuCl3. And then that's where I have to work from the back now. I'm looking for grams of Au. So that means this has to be grams of Au, which was 197 grams of Au per 1 mole. And that means up here must be mole Au. And both of those are 2s. There's the one there and the one there. You do that, if I remember this one, 39. Okay, 38.9. I'm just going to round that to 39. Who had 39 or 38.9? Just to bug people. Okay, hold them up. That's pretty good. We are up to almost everybody. If you're not raising your hand, don't feel bad. You're still a good person. All right? Just you suck at chemistry, let's be honest. JK, that was rude of me. All right. Another practice one. I'll do the chem for you. AlBr3 plus, sorry, not goes to, plus Cl2 goes to AlCl3 plus Br2. All right. 3, 2, 3, 2. I will tell you the mass of aluminum bromide is like 267. The mass, that's grams, this is just saving you some time, is 133.5 grams of AlCl3. So with those, take a couple minutes, plug those in, and see if you get the answer. When you get the answer and it's a whole number, that is fine. Okay, so 30 grams AlBr3, 267 grams AlBr3, 1 mole AlBr3, 2 mole, and that's coming from right here, AlBr3. Coming back to the back, we're solving for AlCl3 in grams. So grams AlCl3, that was 133.5, which is a nice number because it's half of that value. All right, 1 mole AlCl3 and 2 mole AlCl3. 30 times that divided by half is 15. Okay, if you got 15 before we did it, then you're right where we need you to be. Sound good? Okay. The next one requires us to look at something we've never looked at before, and that's this map on your periodic table. So will you have that out real fast? All right. All right. This is a tool that we have been using all along. You just didn't know we were using it. Have any of you had the question of how does he know how many parts there are to the picket fence? All right. At least one of you has. Thank you. A lot of you have. This map is how I know, and it's how you can know. So if you look at what we just barely did, we've been going from grams to grams, correct? To do that with this map, we start on our given side, all right? So we start here, and we end here. In order to start here and go to the end, we have to cross this line. So that's why I put a vertical line on the map. Will you put a vertical line on the map? You are never done until you cross that line. Okay, so what we've been doing today, we've been going from grams to grams, and in order to do that, you'll notice on this map it gives you 3 arrows. So the boxes are the units, the arrows are the steps you take to convert to those units. All right, so if you look, we've been going over 3 arrows, or that will tell you the shape of this picket fence has 3 vertical lines. The number of arrows you go over is the number of vertical lines in your picket fence. You okay with that? So when we very first learned how to do this, We went from moles to moles, and if you were to look on page 10, probably not talking very well, we just had a plus sign. Okay, fine. I'll go sit in my soft chair. We only had just one vertical line, right? And that's because we only went one step. But shortly thereafter, we started going from grams to moles or moles to grams. And if you look at the map, I should just teach you anyway. If you look at the map, if I go from moles to grams, I go over, and I'm not there yet, so I got to go over. Moles to grams or grams to moles took 2 arrows to convert them. So it was 2. You okay with that? Okay, the next step we're going to do is called moles to liters. And now it isn't quite as intuitive, so we'll use this map, and we are going to use this constant. This constant says if you have a mole of anything as a gas, it will occupy 22.4 liters. Okay? So a mole of any atom or molecule, if you have a mole of it, it occupies 22.4 liters. All right, do me another favor and write the word liter right here and over here. Now, I know that most of you know the unit of volume is a liter, but on a test you forget easy things, so we'll make sure that's there. Okay, so if you will look in these problems we're going to do, we're going to go from moles to liters. So I have moles on the start side, or the given, and I need to cross. And you should always cross here. Don't go up and over. Always cross here. So we go over, and then we go up. So that requires 2 arrows, so my picket fence is going to have 2 vertical lines. Are we okay with that? Okay, I know it's written right here, but it bugs me when it's written right there, when I do it. So I'm going to block that out, and we'll work through it. So here we go. Well, first line tool. 2 vertical lines. And most kids like these because there's a constant. You don't have to add any crap up. It's just always 22.4. So the first step I would do is balance. 2, 6, 8, 10. Now I went in a weird order, so don't just write that. It's technically 2, 10, 8, 6. I was just balancing it as I went along. Okay, here we go. So, same thing as always. Start with the number and unit I give you. This is page 11, right? Page 11. I start with 50 liters of oxygen. Okay. Now, there's nothing crazy about what we're about to do. We're going to do the exact same process. If liters are on top, they must come down. So I have liters of O2 right here. I just learned this ratio right here, or here. So liters are always per 1 mole of the same thing. And if I know this, then I know this must be mole of O2. And I'm solving for moles of C3H8. Which means the top here must be mole C3H8. Then I plug in some numbers. The number in front of C3H8 is the number in front of C3H8. The number in front of O2 is the number in front of O2. Now, yes, feel free to reduce that to 1 over 5. That's just fine. Okay, then this number is always the same, 22.4 liters of oxygen per mole. It's here. It's in other places on your periodic table as well. On the far left side, I have all the constants and stuff. It's also on there. So now we take 50, multiply it by, I'm going to reduce this personally. This is 1/5. So I take 50 and I divide it by 22.4 times 5. You should technically make sure these are in parentheses. Okay, type that in. Anyone have it already? What is it? Okay, 0.45. If you do this wrong, you get 11. So if someone typed it in and got 11, you need to make sure that you do it the right way in order of operations. There's a button, like, I don't know, this might ruin your life. Technically, you can ignore me right now. But what I would have done is I would have just made this a 10. And then gotten rid of the 5. That's what I would have done. But if I didn't do that, this is what I would have done. In my calculator, I would have taken 22.4, times it by 5, and then divided it by 50. And that's the wrong answer, right? Because that's upside down. But I know that. So then on my calculator, I would have hit x to the negative 1. And what that does is it flips your answer over, and that would be your right answer. It's not that complicated. If you have multiple numbers in the denominator, it's actually easier to do it that way. But whatever. Like I said, you could A, ignore me, or B, that might have ruined your life. But also, look, if you have 50 on the top and 5 on the bottom, don't waste your time. Yeah, reduce them. That becomes a 10. Whatever. That's my waste of time speech for the day. Okay, now this beautiful pastel color that we chose for Easter. If you don't like it, it's Cooper Clark's fault, which is a sentence that really can be applied almost anywhere. Right? Was that rude? This is recorded, but Kayla won't be offended, right? No. Here we go. We would balance it. This is a combustion reaction, so I start with a 2. I balance the carbons. I take the number with H and put it in front of water, and then I add them all up and divide in half. And I get 2424, which, if you feel like it, can absolutely be reduced to 1212. Yeah, this is back to the homework. Sorry, page 15. Anytime Sydney moves her, no, I will talk, but feel free to ignore me. I'm used to it. This will give me a headache being this close, but I can do hard things. 2.25 liters of CH4. That means liters has to come down here. So the liters is always 22.4 per 1 mole of the same thing. If this is mole CH4, then this must be mole CH4. You can find that number right there. And if you reduced it already and put a 1 there, that's fine. We are solving for mole of O2. So that means this has got to be mole of O2. And you can find that number right there, which is a 4. And yes, I would reduce them if you hadn't already to 2 over 1, just for math. So you take this 2.25 times 2 divided by 22.4, and you get 0.2. Okay? On our way on the next one. Here we go, 35 liters of SO3, 22.4 liters of SO3. If you don't know where this number's coming from, it's from the periodic table. It's the constant we use anytime for liters per 1 mole of the same thing. So I'm going to put mole of SO3 down here, and that happens to be a 1. Remember, it's not always 1, even though the last 2 it has been, I think. That's just random. All right, and then we're solving for H2SO4, which is what causes acid rain. And that was mole, right? So now I have 1 mole H2SO4. And this is around 1.5-ish, 1.4, I can't remember. 1.56? Okay. Okay, we comfortable with that? Okay, today we've done as hard as it gets. And I like Hallie's feedback that I can't believe that I thought this was going to be the hardest thing because someone told me it was. We're doing well. Okay, look for that link in like 20 minutes.